Hello, this is Benjamin. Welcome back. Tonight we're going to be working on the Elephant Trunk Nebula IC1396. It was taken with a Rokinon 135mm f2 lens, operating at f5.6, stopped down to f5.6. So this is a real wide-angle view with the ASI294MC Pro camera. The filters used were an Optolong Extreme, 24 shots at 300 seconds, 6 at 450 seconds, and an Askar D2 Color Magic, 29 at 450 seconds. So approximately 6 hours and 20 minutes of data between the two filters. And it was stacked in Pixinsight WBPP, weighted batch preprocessing with drizzle scale of 3 and drop shrink of 0.8. So here's the stacked images straight out of weighted batch preprocessing. First thing we're going to do is we're going to crop these down some. This is we're working on the 3x drizzle images, so let's crop them down. So with dynamic crop, let's crop about there, and we'll do an artistic crop later. So we carry our blue triangle over to the image that's not selected, and it crops that. Reselect our main image with the crop mask on it and hit the green check. And now both images are exactly the same in every, well, not in every way, in every dimension. So next thing we're going to do is we're going to solve them. So image analysis, image solver, and I'll be back when both images are solved. Okay. Now we want to put a preview before running spectrophotometric color calibration. We want to put a preview on the darkest, most neutral part of the image, which I just happen to know is right here. This dark finger that comes up out of the nebula is probably the best place to put it because it's neutral. And there's no stars, there's no nebula. Actually, even better than that is, let's move it. Let's put it right here in this dark cloud. That makes even more sense. Let's put it right there. These dark clouds are very neutral in this image, and we want our final image to be. So let's run the color calibration, and we're running a Sony color sensor CMOS with the Extreme. Both images were taken with dual narrowband filters, so the Extreme is going to work the best I understand for both images and give us good results. So let's run it on both. Let's cancel these stretches. Let's remove the preview. And let's re-stretch both of these images. Okay. I'm going to run Blur Exterminator correct only on both images. Get these stars shaped up. Now we're going to run Auto DBE, automatic DBE from the Steady Astro tool script. Steady Astro automatic DBE. We'll run that on both images and be back. All right, there we have it. Two flat images, no gradients. So let's go ahead and combine them. We're going to combine them into an SHO image with the utilities DB extract. It's a script DBXTRACT. You select your camera sensor, 294 in this case. the HA03, which is the L Extreme, and the O3S2, which is the Askar D2, and we click extract, and it creates our SHO image without having to do all the intermediate pixel math. Or should I say it does all the intermediate pixel math. I don't have to do it. So let's close this. Let's close our intermediate channels. And this is going to be glaringly probably red or green. I'm not sure which. Red. So we will run a toolbox autolinear fit SHO red to bring the channels into alignment. Okay. This is what we are now working with. Right there. So I want to run Blur Exterminator full, but I want to actually see what it's doing. So I'm going to create a preview. Right there specifically. And I'm going to run a couple samples of Blur Exterminator just to really figure out what it's doing and dial in the numbers. I really like this picture. I want it to be good. So let's do it. I spent 6¼ hours plus dithering time. So let's run it. Let's go with our, what I normally do is sharpen stars 3.5 and sharpen down star at 0.7. Let's make a clone of this so that we can compare a few. Let's run that. That should take like a second. Sorry, 3.6 seconds. Oops. Alright. That didn't work. Alright, let's clone this a few times, and so we have it. Let's run Blur Exterminator at the settings I specified. I like what it's doing with the stars, but I don't see any sharpening or deconvolution of. Let's crank it all the way up to sharpen down stellar 1.00. Run that. Let's see if we see a difference in that. Okay. Let's turn down the sharpen stars some. Keep the stellar, sharpen down stellar at 1. And let's take the sharpen stars down to 0.2. Run this because these stars are very heavily drizzled. They don't need to be sharpened too much. Let's see. That's fine. Alright, so what we need to do now is we're going to run it at this. Let's see, close that. Close that. Close all of our little previews. Preview, delete all previews right there. Let's scroll up so we can see all of our boxes. So what we need to do is actually run Blur Exterminator twice because we want our stars to look the same. So let's run it first on our SHO image. Now we're actually going to be getting our stars from the L Extreme image. We don't want the stars from the SHO image because they're kind of weird. Just by basis of the narrowband image, all the combined stars, we just don't want them. We want them from the L Extreme. So we're going to sharpen our stars in the L Extreme image too. So that'll take an extra second. And we'll extract both sets of stars, and we'll have our stars to put back into this SHO image from the Extreme image. Okay. And we're going to sharpen down stellar down to 0, and we're going to apply it to the Extreme image. Okay. Before we make the mistake, we are going to denoise the SHO image with the stars in there, because that makes a difference. You get all kinds of weird little star artifacts when you denoise something with no stars. It just can't handle it properly. So let's run denoise now. We're doing Graxpert denoise at strength 1.1, and we'll let that run. Alright, Graxpert closed, Blur Exterminator closed. We're done with both. Process, all processes, Star Exterminator. First off, let's eliminate the stars from our SHO image. We don't need the generate star image because we don't want these stars. They're ugly. They're pink tinged. Magenta around the sides. It just doesn't look good. Okay. And we do want our star image from the Extreme. So we'll run it again and generate a star image. There we have it. So let's go ahead and turn our auto stretch off on our stars. Let's minimize the images we're not working with. We're going to minimize that. Minimize that. Let's use the process script, SETI Astro, narrowband to RGB star compilation, OSC dual band filter, green channel ratio. Don't know what that does, so let's just ignore it. Apply star stretch, star factor, stretch factor 6 point. Let's just go 6. Color boost, let's go, we can always unboost them, but let's go to 1.1. And let's take a look at the refresh. Let's show preview. There we are. There's our stars, and that looks great, actually. So let's execute that stretch. Alright, there's our stars, nice and stretched. Minimize that, put that out of the way. Now we've got our image. Oops, integration stars, let's get that out of the way. Let's put that there, because this is the one we want to use to screen the stars. We want to use the NB to RGB stars. We need to remember that, or we'll get unstretched stars. So here's our image. Let's go ahead and stretch it. Let's do our first stretch with, let's be different this time. Let's use the SETI Astro statistical stretch. And let's refresh the preview. Okay. That looks horrible. We're not even going to play with it. We can make it look good, but let's just not worry about it. Let's just go back to hyperbolic stretch, where we belong. And of course we need to turn off the automatic stretch. Might have been our problem with statistical stretch. I get to right there. Stretch again. Okay, right about there. I always click the right button on my trackball and cancel out what I'm doing. And it's just bad. It's bad. I'm losing control of my middle finger, which is a problem in life. Luckily, I don't have that problem when I'm not on the mouse. So, okay. Let's accept that. Let's go into the linear and darken a little bit, but a little bit. Let's leave it there. And histogram transformation. We want to brighten up our brights. We want to darken the darks. We want to take our midtone slider and darken them. That's the contrast slider. That's a contrast slider. It's not the contrast slider, forgive me. Let's take that to right there. This time let's do it again and increase the brights a little bit again. Darken the darks again. And our middle slider we're going to take to the right just a little bit. Accept that. Close out of here. Close out of here. Close out of here. So we're getting some magenta in the corner. So let's try to flatten this out with the script SETI Astro Automatic DBE again. Let's see what we can end up with if we do this. Let's see if we can't flatten this background out some. I don't know if it works on stretched images. So let's see. It's not quite done yet. Don't judge it yet. Don't judge it yet, and you can judge it right now. Did a little bit. Actually, did quite a bit. Very nice. We do have some nebula in this back air in the cloud, so I don't want to take it all out, but it's getting a little much. Now, there is a little bit of a drizzle artifact right here, so I'm going to see. I'm going to take the. I'm going to go into the clone stamp and clone that out. Obviously need a little bit more exposure time. I thought I had enough, but it turns out I don't. So let's see what we can do with the clone stamp. Let's take it up to 60. And take out some of this with just this clone stamp in this area that doesn't seem to have too much nebula. And clone it out. Right there, a little bit more. Okay. There's a little bit right there. Actually, that's nebula. Let's go back and let's leave that alone because that's actually nebula in there. Alright, so we've accepted that. Is this more? Actually, these are just stars. No, that's a little bit of, no, that is some artifact. Let's leave that alone because it's really only visible, and I think the stars that are going to come back are going to cover that up, except not this, the streak, obviously. Let's leave that alone for now. So we are going to go to curve transformation and try to up the contrast a little bit. So our dark area, this is a dark nebula right here. That's right there. So let's darken that. Okay. Our brightest parts of the nebula, it might be right here. That's, average that out to about right there. Looks nice. Accept that. Okay. Let's okay. We're not going to do narrowband normalization. We've got a lot of contrast in this already, so let's just play with it. First of all, let's bring up our process icons, load process icons, the Bill Blanchard, color masks, and whatnot. They're of course on workspace number 1, and I'm on workspace number 2. Highlight them all, right click, move to workspace number 2. Problem solved. First, let's work from the outside in. So we've got a little bit of this red on the outside. So let's pull up a red mask. Okay. Not much red. So let's pull up a yellow mask. Okay. Let us blur this mask. Blur 1, blur 2, blur 3, apply, process, all processes, curves transformation. Alright, what do we want to do with this yellow? Let's see what we're affecting with the green. If we take the green out, we can create more red, orange, which I like. Create this. The red, we want more red. That's nice. Blue, do we want to affect the blue channel? Pull it down a little bit. Not we can make it, there we go. There we go. That's what we're going for. Okay. And do we want to change the contrast? We want to bring it up and bring it up. Okay. Let's accept that. Reset. Close. Close. Mask. Remove mask. Next thing we're going to do is we are going to do a green mask. Okay. Blur the mask once. Blur the mask twice. Blur the mask 3 times. Apply the mask. Process all processes. Curves transformation. Now what I want to do is I want the middle of this nebula to be blue. So let's see what we're working with. Oh, that's pretty. Not what I want in the middle, but that green. I like that C component. Saturate, no, contrast. All right. So let's try a cyan mask. We really want to narrow in on this blue right in here. I could see it. I just have to figure out how to grab it. And that is going to do it. Blur the mask. Blur the mask. Not too blurred, not too little blur, just the right amount of blur. If I can steal from somebody else. If you know who I'm referencing, good for you. Curve transformation. Blue. Green. Okay. Red. There's that button again. Right about there on the green. We want some of the green on the outside. We want green and blue, not just green. I'm not just blue, or not just blue, or just green. We want kind of both. Okay. That looks okay. Now let's raise the contrast to this area. Okay, let's bring up the saturation of this middle area because it's just very desaturated. Let us undo the saturation because it looked funky. Oops, what have we done? We have messed it all up. Tip, do one line at a time. It's a bad habit to get into to do multiple lines at the same time. Saturation, contrast at the same time, because it's just a bad habit to get into. Do one at a time. Okay. Mask, remove mask. Last thing we want to do is a magenta mask and see what comes up, because we've got some magenta in here that we don't necessarily want. We want it to be a little more red rather than magenta, so we will see what our magenta mask captures. Alright, that's going to be... that captured what we wanted to capture, but it's going to be so light, so we need to blow this mask up a little bit with the histogram transformation and make it a little stronger, so we don't have to go crazy with our adjustments in order to see any results. Right there. Okay. Accept that. Not accept that. Go there, there. That's fine. We're going to blur the mask just a little more. Let's apply the mask. Process, all processes, curve transformation. Now, let's take our green, increase the green to kind of cancel some of it out, leave some of the texture. Let's take the red and increase it. Something like that. Because that goes, and see, I did it again. 2 lines instead of 1. It's a bad habit to get into. Because now if I mess one up, I might have to reset the whole thing. We've gone from that to that, which I think is a major improvement. Let's accept that. Let's take our contrast tool, darken the darks, raise the lights, pull this and accept that. And good. Mask, remove mask. Now we got to do something about this. We might end up cropping it out, but let's just go ahead and take care of this abomination right here. We're gonna have to crop. This corner is no good. Let's see what we can crop out of it with an artistic crop. Oh, nope. We're not gonna make that same mistake again, because then we have to crop the stars. Let's add their stars back in and see what we end up with. So script, SETI Astro, mask merge, base SHO, union, add, mask 2 is our NB to RGB stars, and execute. Alright. There's our image with stars. We can of course use dynamic crop to crop the stars to the same size and blah blah blah, but I just didn't want to do it that order. So let's go into dynamic crop, see what we want to keep in, see what we want to leave out, and then we'll figure out how to fix the rest, besides taking more images. Dynamic crop. Let's start the dynamic crop right there and go. We need, of course, the nebula in the middle. Alright, that is the width we want. So let's figure out the height. Where's my calculator? The width, 8168, is what we want. Times 2 divided by 3 means our height should be 5445. Alright, so that's a 2 by 3, also known as a 4 by 6 ratio, which is what I like, because I like to print, and those are a standard size primarily for what I do. So let's accept that, and let's figure out the rest. Let's zoom in. What do we need to fix? Just a little bit around the corner. A little bit on the corner. know what? I'm going to leave it. No. Yeah, no. Clone stamp. Let's take this down some to the radius. Let's see what we got. Radius smaller. 15. Try to get between the stars, not on the stars. Let's clean some of this up. That looks better already. That just looks like nebula. Let's accept that. You know, if somebody blows it up really big, they'll see. But let's not let them do that. So this image is currently (8166 times 5448), give or take. It's about 44 megapixels, 44.5 megapixels. So this is a huge image. But there's your image. That looks pretty darn nice. Let's add a little bit more contrast. Curves, transformation. Darken it down a little bit. Let's see, where do we want this point? Right there. What did that do? It took it from there to there. You like. All right. So, let's call this a finished image. Until I can get more data anyway. A couple more hours, actually 6.5 hours, and these are minute changes at this point. So, probably double it maybe for a really good image. So, you might see this image again in a couple of months. Or next year. I don't know. Can't say for sure, but it gives you an idea where I am on this image with 6.5 hours. 6 hours 20 minutes. Sorry, not 6.5. 6 hours 20 minutes. Let me do one thing. Let me run a. I don't think I'm going to need this. Bill's background neutralization. I think it's going to take all the red out of the. No, it didn't take the red out. It goes from there to there, of which I like the change. Do I like the change? I like the change. Alright. I'm calling it. This is a good image. I'll look at it again tomorrow and may make a few other tweaks before I post it, but this is a good image. So this real time was 53 minutes from the time I hit record on the video to right now. It's 53 minutes, 53 seconds. So I'll give you an idea of real time, what it takes to do a Drizzle 3X image on a good computer. So just a little information for you. So I will see you next time. Thank you very much. Again, my name is Benjamin, and I will see you soon. Bye-bye.